Hello friends, this is VR Patel Park and today I am going to show how to do the piston analysis, which is very important for the mechanical engineer, and it's a very important for the automobile engineer as well, because it's a paramount component in automobile engineering. So here you can see how the piston is moved from the bottom side to upward side and also upward side to bottom side. Here we can see how the spring is work and how the piston is work. In the section view you can see it here how this piston is moved inside the casing. Okay. So let's begin with static structure analysis. In static structure analysis, first we have to select the engineering. First we have to select the material in engineering data and then go for the engineering data sources. We select the aluminum, stainless steel and the cast iron. So you have to click on the general material and it show the below. We have to add the material. So we have to click on this plus button and the grey cast iron for the casing, and for the piston we select the stainless steel. Then we have to go back to the geometry. The geometry section is open, so we have to import the part in this geometry section, or we have to draw, or we can draw the part in the geometry section as per your choice. But I import the part from SolidWorks software. First I drew the part in SolidWorks and then I import the part at here. If you want to show how to import the part from any design software to the ANSYS software, so you can watch my first video. Here you can see the part is imported. Okay, first we put the material and then go for the generate, so part is imported. Then we back to the main page, then go for the model. In model we also do the setup of our geometry and we got the solution as well as the result in the model. So there is no need to open these three things. We got all three things in the model. It's take a few time to open it. Okay, the geometry is here. In which we have to do the first step is to select the material. For the spring we select the material is aluminum. When we provided material in engineering data and then this material we got at here. Okay, when we select the spring, so it shows the detail of the spring at here. Then for the part 2 means this piston we select the material stainless steel. Then for part 1 is casing, so we select the material for casing is grey cast iron, which is very important for the casing and it has a good wearing property, so that's why I select the grey cast iron for the casing. Then we go for the connection, because here you can see the spring is one end of the spring is attached to the casing and the another end is attached with this piston, so we have to provide the two contact at here. So this by default contact we have to delete it. Then we have to apply the new contact by right click and insert, then go for the manual contact region. For the target, here you can see the contact and the target. Here also you can see the contact body and the target body. first we have to select the target. So we select the target at this casing face. Okay, this is highlighted at here, and apply. And another contact part we have to select this face which is attached with this casing face. So I have to do hide body so I can see the better this face. I'm talking about this face. Okay, so in contact region, for the contact I select this face. Okay, apply. So on the first contact is ready. You can see it here. This is the contact body which is highlighted in red region, and this is the targeted body which is highlighted in the blue region. Then go for the another contact for the selections of piston and the spring. Okay, so in the same way we have to select the target as a piston and contact as a spring. So I hide this part so we can see better this one. What I can see. Okay, for the contact I select this one. Okay, then we can watch or we can see the better and the contact as a red region and the target as a blue region. Contact is done, then we have to go for the body to body joint. Why this one? I'll tell you about it. First I'll have to do the cross section view of this one. Okay, how to generate the cross section view. So you have to select this section plane, new section plane, and you have to draw one line. You can see it here, the one line at here. Okay, this is the simple. Okay, in translational joint, because this piston is moved inside this casing. Okay, so for the first scope it shows the two reference. Okay, translational joint shows the two reference. In the first reference we have to select, or I have to select this one. Okay, then for this second reference I'll have to choose the piston outside. So for this I hide this casing so I can see this better. Okay, for translational joint, for the mobile scope I'll have to select this one. Okay, in translational joint, for the reference, this is red region inside the casing part. That's why we cannot see it properly. And in the mobile body view, you can see it here. This is the blue region. Okay, we off the section view. How to off the section view? So click here, and we got the whole part. Then go for the mesh, generate mesh. Mesh is ready. In mesh, you can apply the different kinds of the sizing method. Here, use advanced size function. Click here and then go for proximity, curvature, proximity, and the fix method. Okay, when you apply the proximity and curvature method, it will take the more time compared to off. Then you can also apply the relevant codes Relevant center means these two lines, the gap between the two line, these three line is a relevant center. Coarse means very low, medium, and then fine. If you apply the fine, then the gap between these three lines will be minimized. The meshes is done, then go for the static structure. Insert first the fixed support. In the case of the piston, this phase is attached with the bike tire. So when the bike tire move upward in the downward direction, then this piston move inside. I will show you. Okay. This piston, when we apply the force at here, then this piston is moved inside. In the actual condition, in this casing, we can find out the hydraulic fluid. When we apply the force at that time, it moves upward side, and then the spring is compressed. Okay. So this kind of things we find in the solutions. So I have to apply the fixed support. First I have to close this section. First I apply the fixed support at this face, end of the spring. Fixed support and apply. By this end of the spring is fixed, and then this piston is moved upward side. Okay, so then the spring is compressed. Then go for the displacement. Also we have to provide the displacement of this face. I'll show you why we have to provide the displacement. If I do not provide the displacement, what kinds of the result we will get, and if I provide the displacement, what kinds of the result we will get, we will see. You can see the y direction is upward side at here, so I'll have to provide the 40 mm at upward side because it moved 40 mm upward side. Because the casing, inside casing gap is up to the 50 mm, so I provided 40 mm at here displacement. It moved up to the 40 mm at upward side. Then I'll provide the force at this bottom side. Why I provided? I said earlier. And it is also in upward side, and we have to provide upward side, so y direction is in upward side. So in component we have to select the component. Okay, so we can provide it a better force up to 500 Newton at upward side. You can see the sign at here also. Then the bottom of the casing. Then for the solution, I'll apply the total deformation. You click the solution and then you will get the total deformation and stress. And then go for the solve. The result is ready, and you will see. For the total deformation, in total deformation we can find out, we can get at the result. This spring is compressed. You can see in the mesh the gap between these two springs, and at here in the total deformation you can see at here. I click the play button in animation, so I'll get the better result at here. The blue region is show at the total deformation at edge 0, okay, and at the red region show it get the 40 mm deformation. The deformation unit is mm, so at the red region is the maximum deformation 40 mm, and at the stress in this red region we find the region 19 megapascal, 99 megapascal. Unit of the equivalent stress is 99 megapascal, and at the blue region we find the stress is minimum, around the 12 or 8 megapascal. I said to you, when displacement, when we not provide the displacement, what kinds of the result we will get? I'll suppress this body and then go for the solution. Our result is ready. We will see. In the total deformation, you can see it here when we not applied the displacement. You can see it here when our the piston is moved and our spring is totally in the deform. Okay, our spring is deformed when we not apply the displacement in this casing. Take a look at this. Look at this in total deformation animation. Look at this. In which kinds of the manner are the piston is moved. Okay. So the displacement is work like the hydraulic fluid, as a hydraulic fluid in this casing. So that's why we have to provide the displacement, okay, unsuppressed, and then go for the solution. We will get the actual result. So we will get the result when we apply the displacement. Get the total deformation, you can see it here, the total deformation, okay, when we apply the displacement. And displacement is work like hydraulic fluid in this casing, how it's compress and uncompress. And if you want to get the print view, if you want to get these things in one page, so you can click on the print view and get this print of the total deformation things. When you click on equivalent stress, then you got the equivalent things, equivalent stress print view, and we will also get the report at here. We can get the report, all the report from the which kinds of the material we will apply, what kinds of the connection we applied at here, and what kinds of the joint, as well as what kinds of the boundary condition, fixed support, displacement, forces, and what kinds of the stress or what kinds of the deformation we will generate at here. So we get all amounts of the detail at here. So thank you so much, and please subscribe and share my channel. I hope you like this one.